Hello students, welcome back. In this video we're going to go through Chapter 1, Section 2, Types of Data. So a major use of statistics is to collect and use sample data to make conclusions about the populations. Well, that's pretty much the whole point of the class. So let's now look at what a parameter is versus what a statistic is. A statistic is a numerical measurement describing some characteristic of a sample. A parameter is a numerical measurement describing some characteristic of a population. So to put that into layman's terms, if you're making some kind of statement about a sample, you're dealing with statistics. If you're making some kind of statement about an overall population as a whole, you're dealing with parameters. And that's not hard to remember. Think statistic, sample, SS, parameter, population, PP. Just kind of a little way to memorize that. Let's look at an example. So there are 17 million blah 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 high school students in the United States. In a study of 8,505 high school students, 44.5 of them said that they texted while driving at least once in the past 30 days. So now we're going to look at the parameter versus the statistics, the population versus the sample. So the population size is 17,246,372 because it's about the because it's a parameter since we're dealing with the population. But we know that it's pretty unrealistic to survey every single high school student. So we aren't going to be able to make our parameters directly. Instead, let's look over to a statistic. We can do that. So the sample size of 8,505 is a statistic because it is based on a sample, not the entire population. The value of 44.5 is another statistic because it is based on the sample. That 44.5 number is based on the sample size right here, not this right here. We're making conclusions about this based on the information we gather from this. Next, we'll talk about qualitative versus quantitative. So remember, quantitative is numerical, and it is numbers representing counts or measurements, the weight of a boxers, the age of respondents. Those are values, those are numbers. It's a quantifiable amount. And then we have categorical or qualitative, and these consist of names or labels or really anything that's not a number. So the gender, male or female of professional athletes, that's qualitative. You can't have a count or a measure to that. And then shirt numbers on professional athlete uniforms. Those you might say, well, number 11 is a number, so that's quantitative. No, because that's just a substitute for a name. Being number 11 or number 5 doesn't really tell you anything else other than that they have a different person who's wearing that shirt. So we are really going to be working a lot with quantitative because that's a way for us to actually have a tangible measurement based on the value. So they can be described further by looking at either discrete or continuous types. Okay, discrete data result when the data values are quantitative and the number is finite or countable. So the number of tosses of a coin before getting tails. There is a direct, hard number that would be that answer. Continuous data is that there are infinitely many possible quantitative values where the collection of values is not countable. So the length of distances between 0 and 12. Well, you'll say that there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, but then you can look at that even further. 1.1, 1.2, and then 1.21, 1.22, and it can go on and on forever. You can have infinite amount of decimal places, so you can keep dividing up that gap in between them forever. So there are infinitely many possible ways, whereas discrete, there is only a set, absolute, hard, finite number. Levels of measurement. And here's our next topic. Another way of classifying data is to use 4 levels of measurement. And we're going to talk about each of these and then give you an example that follows. Nominal, ordinal, interval, and ratio. Here is a quick summary of them. Ratio, think of heights, lengths, distances, volumes. Interval, the differences are meaningful, but there is no natural zero starting point, and ratios are meaningless. So to put your body temperature divided by my body temperature, that's not really going to tell me much. Ordinal is data can be arranged in order, but differences either can't be found or are meaningless. And then nominal is that there are categories only. Data cannot be arranged in order. So eye colors, well, you can't really quantify it. So having green eyes versus brown eyes, it can't be arranged in descending, ascending order, etc., etc. So let's look at nominal. Nominal is characterized by data that consists of name, labels, or categories only, and the data cannot be arranged in such an order. So survey response of yes, no, undecided, anything that cannot be put into a list of ascending or descending orders. Ordinal levels involve data that can be arranged in some order, but differences obtained by subtracting the higher minus the lower between data values either cannot be determined or are meaningless. So if you have course grades, that would be an example of an ordinal level. Interval level involves data that can be arranged in order, and the difference in data values can be found and are meaningful. However, there is no natural zero starting point at which none of the quantity is present. So even year zero, well, what does that really mean? It's not like saying that there's zero year in the world. What does that actually mean? Or it's just kind of hard to have a starting point where there is no of the available thing of interest, and then X number of times lapse goes on, and now you have this many. So you can actually measure the change in population or change in the quantity of some kind of presence. Finally, ratio level, and this is the one that we are usually most concerned with. Data can be arranged in order, differences can be found and are meaningful, and there is a natural starting point, where zero means that there is no quantity is present. So that really lets us compare apples to apples. So here's your summary of all that values. Here's a little flow chart that helps you determine if you were given a type of data to be able to figure out which of the levels of measurement it is. And that concludes Chapter 1, Section 2. Thank you.